Hi guys, let's look at the next question. The next question that we do is question number 3. Before we start, let's just revise the two tests of similarity. AA test, not in fact two, not two, three. Side, side, side and side angle side. In similarity, sides are in proportion, the corresponding sides are in proportion and the corresponding angles are equal. Perfect. So now let's just look at some questions and see how we can move from here. So P is point on side BC of a parallelogram ABCD. So let's just draw a rough diagram of a parallelogram. Okay, so this is parallelogram ABCD. What they're saying is P is a point on side BC of parallelogram ABCD. If DP is produced, means AB produced at L. Okay, so if I am producing this and I am producing this as well, they meet at point L. This is point P. Perfect. Prove DP is to PL is equal to DC is to BL. Perfect. So let's just see what we need to prove and let's write it in the fraction form because we've been writing it in the fraction form till now. So what they want me to prove is DP upon PL is equal to DC upon BL. Now, easy way of trying to figure out which triangles we need to prove similar is look at the numerator of these two and see which triangle do they form a part of. DP and DC, which means DP and DC form a part of triangle DPC. So we are looking at triangle in triangle DPC. This small trick works almost every time. Even if it doesn't work, it'll give you a big hint. We'll get to some questions where this trick may not work, but more about that later. Let's look at compare denominator and denominator. So PL and BL. So PL and BL, which means we're looking at triangle BPL. So these are the two triangles that I'm looking at, DPC and BBL. Let's see if I have anything equal. Yes, angle P here and angle P here will be equal. Why? These are vertically opposite angles. And angle D here and angle L here will be equal because these are alternate angles because this is a parallelogram. Perfect. So I've got two angles equal, which means I can prove them similar. So let's just look at this. Number one, angle DPC is equal to angle LPB. Reason is vertically opposite angles. Done. Let's look at the second one. The second one would be angle PDC is equal to angle PLB. Reason is alternate angles. So number 3 would be triangle DPC is similar to triangle. Let's look at congruence. Let's look at similarity. So correspondence is D with L. P correspondence is with P. That leaves B. So this is by AA test, which means we can write the sides in proportion, which means it will be DP upon LP is equal to DC upon LB is equal to PC upon PB. This is corresponding sides of similar triangles are in proportion. Done. What do we need to prove? DP and PL. So we have DP and PL done, and we need DC and BL, which is done. Therefore, that's number 5. DP. Let's just write it in the form that they want. DP upon PL is equal to DC upon BL. So we've looked at the first two of this proportion. So this is hence proved. Next, let's look at the second part that they want us to prove. So let's again write it in the fraction form. It'll help us identify which two triangles to look at. So they want DL upon DP is equal to AL upon DC. So let's look at these two, numerator and numerator. So DL and AL. So DL and AL form the triangle DAL. So let's just write this down in triangle DAL, and in terms of denominator DP and DC. So DP and DC form triangle DPC. Let's see what we get. Number 6 would be anything equal in these two triangles. Yes, I notice that angle D here and angle L here are equal. So let's write that down. Angle DAL. So we will need to write angle, this triangle first. So angle DLA is equal to angle PDC. This is alternate angles. Next, what's the second angle which will be equal? Let's look at this again. I realize angle A and angle C are equal. Why are they equal? Because these are opposite sides of the same, opposite angles of the same parallelogram, which means I have the second angle. In case you're finding it difficult to understand, let me just draw a rough diagram here for clarity. This is D, this is A, this is L, and the second one is DCP. So we got angle L here and angle D here equal, and we got angle A here and angle C here equal. So which means, let's just write this down. Angle DAL is equal to angle PCD. This is opposite angles of the same parallelogram. Done. So we've got two angles equal, which means triangle DAL is similar to triangle. Let's see the correspondence. So angle D is here is corresponding to angle P. So this is P. Angle A is corresponding to C. That leaves D here. So DAL, this is by AA test. What it means is DA upon PC is equal to DL upon PD is equal to AL upon CD. This is corresponding sides of similar triangle. And notice that this is extremely important to get the correspondence right, and then after that you can look at 1 and 2 and then look at 1 and 2. If you look at 1 and 3, look at 1 and 3 here. Becomes simple. Let's see what they want. DL is to DP. So DL is to DP, which is here, which means number 10 DL upon DP, and then AL and DC is equal to AL and DC. Done. So this time we looked at number 2 and number 3. I realized that they've asked me a question in the ratio form. I wrote my answer in the fraction form, so I will lose marks here. That's why I should write this as dP is to PL is equal to DC is to PL. If they have asked the answer question in the ratio form, we will write it in the ratio form. If they ask it in the fraction form, we write it in the fraction form. So this is DL is to DP is equal to AL is to DC. Hence proved. Done. Let's look at a long question. Let's look at the next question. The next question that we do is question number 4. Question number 4 says, in quadrilateral ABCD, the diagonals AC and BD intersect each other at point O. Let's just draw a rough diagram. So this is our quadrilateral ABCD. The diagonals intersect at O. Okay. Done. A, B, C, D. Diagonals intersect at O. If AO is equal to 2CO, so if AO is equal to 2CO, so let CO is equal to X, therefore AO is equal to 2X. Perfect. So if CO is X, AO is 2X. Perfect. Number 2, and BO is equal to 2 times DO. Okay, so let DO is equal to Y, therefore BO is equal to 2Y. So DO is equal to Y, BO is equal to 2Y. We need to prove triangle AOB is similar to triangle COD. So we are basically looking at this triangle and this triangle on the top. Now remember the test of similarity, SSS, SAS and AA. No mention of parallelogram, no mention of anything else. So don't think AA will be feasible. I can definitely get angle O here and angle O here equal, because this is the vertically opposite, which means I'll have to look at either this or this. In any case, no mention of the third side. So let's try if we can get this. Quick revision, what this means is that the included angle is equal and the sides in between which the angle is there are in the same proportion. So they seem to be in the same proportion. This is 2x upon 2y, this is x upon y. Let's just write that down. Number 3, CO upon DO is equal to x upon y. Number 4, AO upon BO is equal to 2x upon 2y, which is equal to x upon y. So from 3 and 4, what we get is AO upon BO is equal to CO upon DO. Perfect. So that's my point number 5. Now let's look at these two triangles. In triangle AOB and triangle COD, what I have is number 6, AO upon BO is equal to CO upon DO. This is from 5. And number 7 would be angle AOB is equal to angle COD. This is vertically opposite angles. What this means is these two triangles are similar by side angle side. Angle is equal and the angle is the sides between which the angle is included are in the same proportion. So let's just write that down. Number 8, therefore triangle AOB is similar to triangle COD by SAS test. Done, which means our first part is done. Next, OA into OD. Let's just look at the corresponding sides which will be in proportion. If I take this as OA upon OC is equal to OB upon OD is equal to AB upon CD. This is corresponding sides of similar triangles are in proportion. We need to look at OA and OD. So maybe if I look at these two, it will give me the same one, which is OA multiplied with OD is equal to OB multiplied with OC. This is the second part that they wanted us to prove. So hence proved. Done. So we've done a question which had side angle side. We've done a couple of questions with angle angle. Let's see if we'll get a question with triple S, which is side side side. Let's look at the next question. The next question that we do is question number 5. A very interesting question. Please read it carefully. In fact, you can even put a small star on this question. Anyway, in triangle ABC, angle ABC is twice angle ACB. Okay, so let's just draw this triangle. Okay, so this is triangle ABC. Angle ABC is 2 times angle ACB. Oh, okay, so if this is x, then this is 2x. So let's just write that down. Let angle ACB is equal to x. Therefore, angle ABC is equal to 2x. Done. Bisector of angle ABC. Okay, so this angle is getting bisected, meets opposite side at P. Right, so basically if this is bisector, which means this becomes x, this is also x. Good. And meets the opposite side at P. We need to show that CB is to BA is equal to CP is to PA. Now let's look at which two triangles we should look at. So what we have to do is to prove that CB upon BA is equal to CP upon PA. So if you remember the small trick that I had talked about in the previous question, which is compare the two triangles, two sides on the top and two sides at the bottom, and see if you can get anything. So you have CBP, which is this triangle, and ABP, which is this triangle. Will I be able to prove them similar? Maybe yes. Let's try. And if it works, well, why not? So number 2, if I have this as x, then this triangle definitely is an isosceles triangle, which means BP and PC are equal. Done. In this second triangle ABP, I have only one angle given. Can I try and figure out another angle? Yes, I think I should be able to get this angle, because this is the exterior angle of triangle CBP, which will be equal to the sum of these two angles, which should this be 2x. But I am still not getting anything. This is x, this is 2x, this is x, this is x. Maybe this is the question where this trick does not work. Why this is not working, maybe I'll come to it in a couple of minutes. But for now, this trick doesn't seem to be working. Let's see if I can get something else. Two triangles where I can get some common angle. I notice if I look at the big triangle, which is ABC, I have this angle common. And if I look at ABP, let's look at the top triangle, which is ABP. So angle A and angle A will be common. Angle ABP is x. We got angle APB as 2x, and we've got angle C as x, and we got angle B as 2x. Done. Should be able to prove them similar even without looking at 2x. Perfect. So let's just write this down and see if this will help us get somewhere. Okay. So in triangle ABC and triangle ABP, number 2 is angle BAC is equal to angle PAB. The reason is common angle. Number 3 would be angle ACB is equal to angle ABP is equal to x. From 1, and since BP bisects angle ABC, so that's why both of these are equal, which means number 4 would be triangle ABC is similar to triangle. Let's look at the correspondence. A corresponds to A, B, which is 2x, corresponds to P, and C corresponds to B. So ABC is similar to triangle APB by AA test. Which means let's write the proportionate sides, which means AB upon AP is equal to AC upon AB is equal to BC upon BP. This is corresponding sides of similar triangles. Let's see if this has helped us get closer to what they want. If I look at AB multiplied with BC, I think I've got my second part for sure. AB multiplied with BC will give me BC multiplied with will give me BP multiplied with AC. I think I've got my second part for sure. Right? So let's just write that down. Number 6 would be AB multiplied with BC would give me BP multiplied with CA. This is answer to part 2, hence proved. But it still hasn't given me my first part, which is CB is to BA. Let's see, where do I have CB is to BA? I have CB, I don't have BA here. So if I take BA from here, maybe I will get something. CP, I don't have CP, and I have PA. Okay, so I have BC done, BA done, CP is missing, and PA is there. So maybe I should look at the first and the third. Okay, so let's just write that down. From 5, what I get is number 7, AB upon AP is equal to BC upon BP. They wanted BC upon BA, so let's just exchange this, which means BC upon BA. I'm just exchanging these. This can be multiplied and taken on the other side. BC upon BA would be equal to BP upon AP. So I've got CB, I've got BA, I've got AP. This is the missing link. Is there anything that we've already done? Yes, we did that BP and CP are equal because this is an isosceles triangle. So instead of BP, I can write CP and this will be done. Let's just write that down. Number 9, BC upon BA is equal to PC upon PA. Since triangle BPC is isosceles, therefore BP is equal to PC. So I have replaced BP with PC, which gives me the answer that they want, which is CB is to BA is equal to CP is to PA. I hope you realize why we did not get that trick here initially, because we got an isosceles triangle and they replaced PB with PC. That's why we did not get this. Had we looked at this one, it still would have worked. But anyway, thank you so much. That brings me to an end of this question video. Homework question for you. Homework question for you would be question number 2. That's about it. Thank you so much. Take care. I'll see you with the next video.